Epitaxy is a combination of two words. Epi means upon and taxi means order. That is ordered upon. Now what is ordered upon what? Epitaxial layer is ordered upon the bulk crystal of wafer. So epitaxy means the growth of a single crystal film on the top of a substrate. Depending upon the material used, epitaxy is classified into two types: homoepitaxy and heteroepitaxy. Homoepitaxy, when same material layer is grown on the substrate of the same material. Example, in BJT, N-type silicon layer is grown on the P-type substrate of a silicon material. Heteroepitaxy, when a layer grown on the substrate of the different material. Example, SOS. SOS, silicon and sapphire. Sapphire is basically aluminium oxide Al2O3 having a hexagonal lattice pattern, and silicon has a diamond pattern. Three rules are strictly followed for heteroepitaxy: that there should be no chemical reaction between the substrate and the epitaxial layer, no lattice mismatch, and there should be no thermal mismatch. But only the first rule is stringent. Lattice mismatch can be tolerable up to a certain limit. Lattice mismatch refers to the strain in epitaxial layer, that is to the certain thickness it can be tolerated, but beyond it does not tolerate. Example, silicon and sapphire has a lattice mismatch. Sapphire has a hexagonal lattice pattern and silicon has a diamond pattern. And aluminium, gallium arsenide or arsenide, they have no lattice mismatch. Now, based upon the reactant and the state of the material, epitaxy can be classified into three types: liquid phase epitaxy, vapor phase epitaxy, and molecular beam epitaxy. Liquid phase epitaxy and vapor phase epitaxy, in this, chemical reactions are involved, whereas in molecular beam epitaxy, no chemical reaction is involved. Basically, for silicon, vapor phase epitaxy and molecular beam epitaxy is used. Liquid phase epitaxy, as the name suggests, it is done in liquid phase. Reactant solution is cooled down. Let us take an example of gallium arsenide. We dissolve the solution of gallium arsenide in gallium and cool down, which led to the formation of a precipitate of gallium arsenide. As its temperature reduces and solubility reduces, when this PPT comes in contact with the substrate, it gets deposited on the substrate. As silicon has high melting point, it cannot be used in liquid phase epitaxy. Now, vapor phase epitaxy, as the name suggests, it is done in the form of a gas or liquid with very high vapor pressure, so that it can be vaporized easily. Here it is a sample and a controlled gas flow. The distance between the gas flow and the substrate is known as boundary layer. The gas reacts with the substrate and gets deposited on its substrate. Here the gas flows. Here the gas